The traverse function is used for a variety of things. A lot of times it'll be surveying, entry boundary data, or just simply going around, say, a house perimeter north, south, east, west to a precision distance. So a little bit about the traverse prompt. Before I start, I'm just going to change the annotation style to be bearing top, distance bottom, just so that we could see what's happening after I enter the data, so that we have something that will verify the entry. So I'm going to hit the traverse prompt and ask for the first point. Because there is no points that exist, it knows that, so it's asking you to digitize with the left button the first point. And now the prompt says two things. It says bearing distance or bearing quadrant distance. So for example, bearing quadrant distance, if you were a surveyor, would be something like this: 45, and then the format would be point, 12 minutes, 45 seconds. 0.1245 would be 12 minutes, 45 seconds. And then a quadrant of 1 would be northeast, and then 200 feet. That would show the bearing quadrant distance from that first point I digitized. Or I could do something like this, where it says bearing distance. I would say south 78.5612, south 78 degrees, 56 minutes, 12 seconds, east. So I put an S and an E, and then 350. Enter that. Either one will work, and you can intermix them as you work. Northeast is quadrant 1, southeast is 2, southwest is 3, northwest is 4. Quadrant 6 is a deflection angle. So if I came down on that bearing and I wanted to add 45 degrees, I would say 45, quadrant 6, 100 feet. And that would be a 45-degree deflection. That's a surveying term. So you're looking at the foresight of your instrument, and you want to deflect right or left. Left would be minus 45, quadrant 6, 200 feet. You can use quadrant 6 and 7. 7 would be an angle off the backside. For example, 90 degrees, quadrant 7, so it'd be turning a clockwise angle from looking at the point just computed to the previous point, and let's say it's 50 feet. That would be a angle to the left. And now we'll discuss quadrant 8. Quadrant 8, let's say I want to go curve to the left, so I'll say negative 89 degrees, 45 minutes, quadrant 8, and a radius of 300 feet. It swung an arc, and you can see the information on the top of the screen of what it computed. Again, I'm looking at a foresight. If I want to continue along the tangent, I just say 0.6 and 150 feet, and that would be along the tangent. Now let's say you don't have the internal angle of the curve, but you have the length of the curve. That would be quadrant 9. So if I wanted to go again a curve to the left using quadrant 9, negative 500 foot length, quadrant 9, and negative would be left, and then 300 feet. Another thing that you could do, which is interesting, if you want to go due north, south, east, or west, you just have to type in the letter W, for example. So I want to go due west 200 feet. Now I want to go due south 250, S 250. Notice I don't have to put a space in there. Now I want to go southeast. What would happen if I type in SE and then 150 feet? So that's south 45 degrees east. What if I wanted to just put in the radius and the internal angle of the arc? I would say R for radius. I could do this, 200 feet. It'd be an angle arc to the left, AL, 45 degrees, 12 minutes, and then 54 seconds. And then it would swing that arc. If I had a compound arc, because again it sets a tangent, I could do something like this. And that would be, I'm going to say arc to the left, 78 degrees, 32 minutes, R, 90. Now notice I switched the two. Before I had the radius first, and now I have an arc to the left. The delta is first. It doesn't matter in the order. I'm going to hit File, and then New. I'm going to show you a little trick. Notice there's a right button trick there. So this would be a lot of data to enter by hand, and a lot of sites are just simple. You could just enter by hand, that's no problem. We've got a legal description of a complex boundary. This was created actually by LandMentor. I want to enter all of this data in, and the problem with hand keying the data is it's extremely easy to make a mistake. I've reduced this language to the actual language that the software understands. I'm going to make a mistake. I'm going to take and then remove the 1 from this north 37 degrees east. So I'm 1,000 feet off, okay? I'm going to save that. So what I'm going to do is I've digitized the beginning point, and I'm going to right click, not left click, but right click. It's going to ask for an initial point, and then I'm going to go down to my temporary, and this is the one with a mistake in it. And you can see, obviously, it doesn't close. So what you could do is take and look at the various bearings and distances, check it with your data, and then take a look at the chart, and you could see, well, wait a second, I missed a 1. I'll file this away again, save it, so it's the same name, and I'm going to say File, New. I'm going to digitize the point on the screen, and then I'm going to right click my initial point, pull up the same file, and it closes. But it doesn't close really because of the rounding of angles and distances. The site actually won't close. So if you could see, I start off with this line and it went around, so point 1 to 2, and then it ends with a point 29. If it closed, 1 would equal 29. Because there's a little bit of error when you're entering this data where you can see that it doesn't close. So you really have to force a closure. And this distance is very close, but unless it's a perfect trapezoid or rectangle, these sites are never going to close. So what you do is you would force a closure. If it's very, very close like this one, what you would do is just either intersect 2 lines, or in this case we began in a curve. I'm just going to take and create a fillet from here to here of 80 feet, and then that forces the closure. Caution is, don't do this if it's way off. Don't force a closure if it's more than 100th, maybe 1 or 200ths of a foot off, because it should be that close. Otherwise, you're going to throw off the calculations. And then if I wanted the area of the site, I just would go in, type in site. Now it closes, and you can see that's the square footage and the acreage. The other way this exact same thing works, now what we did before was we used this format, this bearing and distance format. You could do it this way, which would be digitize, right click, initial point, and if we look at legal description A, which works the exact same way, that one is the bearings and quadrants, and actually can intermix these. I could turn this into something that looks like this. That was 3 south west, and that will work exactly the same.